All right, so here's our lesson on adding, subtracting, and multiplying polynomials. Anything that you've done way back in grade school with regular old numbers, we're going to do with algebraic expressions, some polynomials. So we just have one objective here, find the sum, the difference, and the product of something that we're calling polynomials. So before we get started on that, I've got this warm-up question here. This is going to be what is called Pascal's triangle. Let me throw some numbers in it real quick here. And what I want you to do is I want you to take a look at this and see if you notice what the pattern is to make Pascal's triangle. Pascal is just a mathematician who came up with this. Pascal, pretty famous mathematician. He's considered the father of probability theory. You know, rolling dice and stuff like that, yeah. So this is one of his contributions to mathematics, one of his many ones. See if you can figure out the pattern, and when you do, come up with the last two rows in that. So please pause the video and give it a try. Okay, so did you see that the pattern, at least part of the pattern here, is I have ones on each of the sides here. Okay, so I could at least get each of these digits. I know those are going to be ones. Okay, now in order to get the numbers that are not ones, you add up the two diagonally that are right up above it. For example, this number 2 comes from 1 plus 1, gives you 2. And the number 3 here comes from 1 plus 2, that equals 3. That 3, same thing, a 2 plus 1 gives us the 3. It's kind of like the Fibonacci sequence. Do you remember Fibonacci sequence? In order to get one of the numbers, you add the 2 that come before it. This 4 comes from 1 plus 3. The 6 comes from 3 plus 3. And the 4 here again comes from 3 plus 1. When I say Fibonacci sequence, actually the Fibonacci sequence is hidden in here as well. Anyway, so let's come up with the next row. So the next row, I know I need to start with a 1. This digit here is going to be a 5 because 1 plus 4 is 5. The next one is going to be a 10 because 4 plus 6 gives us the 10, and so on. So there's our next column, our next row of numbers. Okay, and then the last one, of course, the beginning and the end is 1. The next little hexagon here is going to be 1 plus 5 gives me a 6. The 5 plus 10 gives me a 15. 10 plus 10 gives me a 20, and it's kind of symmetric here, so let's fill in the rest of the digits here. There you go. There's Pascal's triangle, and we're going to use this at some point to help us take powers of polynomials, as you'll see. It's be towards the end of the video. It's pretty sweet. Okay, so objective 1, being able to add, subtract, and multiply polynomials. And here is a picture of a roller coaster at Six Flags. And the reason why I put it in here, as you will see in the future, whenever we go to graph polynomials as functions, the graphs kind of look like roller coasters. Peaks and valleys and things like that. So something to look forward to. Okay, so let's, this first video is just going to discuss a whole bunch of vocabulary that you need to know. So the first one is, just a second. All right, so where were we? I think we were about to talk about what the heck polynomials are. So I've got 2 columns here in this table. This side over here, these things are polynomials, these things are not polynomials. I want you to take a second and look at these things so we can kind of decide, just by similarities of those items, difference between those items, what makes a polynomial. Okay, so you take a look at each of the ones, each of the expressions in the polynomial column. You might just see expressions, some algebraic expressions, things that you're used to, right? You have x's raised to a power. You have like regular old constants. Maybe out here at the end you've got coefficients on those x's and things like that. So they're expressions similar to things that you've seen before, right? Nothing kind of crazy or kooky. Over here on the not polynomial column, I've got things like I can't have 2 different variables being multiplied together. Okay, so that's something I can't have. The second one there, I can't have any square roots there. When sometime in the future we're going to learn that the square root can also be represented by an exponent, and it's an exponent of 1/2, and that's going to be a bad thing. For polynomials anyway. And then the last one, look at that thing. It's an algebraic expression, but it has exponents that are negative integers. If I look at the ones of the polynomials, there's no negative ones. There's no square roots in there. Okay? And it's those kind of things that make an expression a polynomial. So here is the definition of a polynomial. Polynomial in x, so x is our variable, is an expression of this form. And it looks kind of complicated here. A sub n times x sub n. The n's are just whatever number that is. So for example, if this is, this could be something like 3x to the 5th power, where n is 5 and the a sub n is the 3. Plus dot, 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 dot. And then you keep decreasing in the powers until you get nothing left over. So this one right here, x is to the 1st power. So you can see that the powers of the x's are just decreasing. And the last one is as if I have x to the 0 power, and as we learned before, anything to the 0 power is 1, so it's as if you don't even write that. And the last term there is just a number. It might be something like plus 12, right? Number, no variable on it. Okay, so first thing is something about the exponents. All of the exponents are non-negative integers. So we don't have any negatives up there. You could have 0, and you can have positive integers, and that's it to be a polynomial. Okay, here's another word. It's called degree. The degree of the polynomial is going to be our n. Whatever that number is, n. And to simplify this even more, what that means is that it is the highest power of any variable that's in there. Okay, it's the highest power of any variable in there. So let's look back at this previous slide here. So if I look at this first one here, the degree here is 2. There's no other terms in it. The degree is 2. And the next one here, the highest power I have is 4, so its degree is 4. I look at the last one here. This last one has a power of 2. It's the highest power. Its degree is 2. Okay? All right. So the next thing is talking about the coefficients. The coefficients are the numbers that we're multiplying times each of the variables. Okay, all of the coefficients for polynomials, they have to be real numbers, right? We don't have anything imaginary in there. It's not like we've even talked about imaginary numbers that much anyway. Okay, the first one, the one that's on the term with the highest power, the a sub n here, is the leading coefficient. Okay, leading coefficient goes with the term with the highest power. Okay, and the number that doesn't have a variable attached to it, which is the a sub 0 here, that's our constant term. It's called constant because it doesn't change because you're not multiplying it times any variable. So again, let's go back here to these. And our leading coefficient of the first one is the number 2. Our constant term is as if I have a plus 0 here, and so our constant term is 0. Okay. On the second one, our leading coefficient is a 1. And our constant term is negative 81, right? On the last one, our leading coefficient is also a 1, and our constant term is the 4. Okay? All right? And then we put it in standard form by just simply writing the exponents in decreasing order, starting with the highest power, and you descend in degree as you go along. It's pretty easy to do, pretty simple to understand. Okay? All right, so a couple of more terms. I've got monomial, a binomial, and a trinomial. And I think these are things that you've heard before. Monomial just means I have one term in my polynomial, right? 2x squared. A binomial means I have two terms in my polynomial. And then finally, a trinomial means I have three terms. And those are the only special ones that we use for number of terms. All of these are considered polynomials. Even though it has one term and we call it a monomial, it's just a kind of polynomial. Okay? Anything that is greater than 3 terms, if it has 4 terms, 5 terms, we just, in general, call it a polynomial. Okay? All right, here's some more vocabulary. Whatever degree that you have for your polynomial, remember which is the highest power, it has a special name. So if your degree, your highest power is a 0, that is a constant polynomial. The one that we're most familiar with so far this year is linear. Linear means that your polynomial has the highest degree is 1. Quadratic, you may remember also from Algebra 1 and maybe even in geometry, the highest power is 2. So those are ones that you've seen before. So some new ones might be cubic, where your highest power is a 3. A quartic when your highest power is a 4, quintic when the highest power is a 5, and everybody's favorite, sextic, when the highest power is a 6. There are more names for other ones, but these are just the ones that I'm showing you, expecting you to know these. So here's some actual examples. Now, these are not just polynomials. These are polynomial functions that I have here because there's an f of x right out front. Okay, so let's look at some of the vocabulary that we've talked about before. What would be the leading coefficient of this first polynomial? I'm going to use a to be the leading coefficient. Leading coefficient here is 0 because there's no x term, okay? But c is what I will use for the constant term, and the c is the 42 on that one, okay? The degree, of course, is 0. It's in the, that's listed for us. Okay, if I look at the linear one, its leading coefficient is 3, which is the same thing as slope. And our constant term is, on this one, a -7. For the linear one, that's the same thing as the y-intercept. Okay, let me just skip down here to maybe the quartic here. The leading coefficient is a 7, so a is equal to 7. And then finally, our constant term here is the last thing here, which is -1. Okay, so just complete vocabulary here in this first video.